Today, we're going to talk about friction. When a person or fighter pushes or plants their feet, there is a threshold, a friction threshold that will determine if the object stops or keeps sliding. When the fighter's foot hits the canvas, static friction is applied. The touching materials make up the coefficient, the foot and the ground, and whatever you may have stepped in on the ground. Once your force crosses a threshold of maximum static friction, matching the coefficient of static friction times the normal force, you've slipped or slid. We're going to use Dawn dish soap to simulate blood and sweat on the canvas. We've built this emulation of a fighter with help from Claude. Fighters slip on blood. Every fight fan has seen it, but in every UFC game ever made, a slip is just an animation someone decided to play. I wanted to know what actually decides it, so I built the physics. When he plants that back foot, he's asking the floor to stop him. The top bar is how much grip that move needs. The bottom bar is how much the floor can actually give. On dry canvas, there's plenty spare. Switch it to blood, and the floor can't cover it. The foot leaves. This ball is his center of mass, the one point you can treat his whole body as sitting at. And the circle on the floor is where his weight is headed once you account for how fast he's moving. Here's the thing. He's not falling because his weight is outside his feet. Sprinters do that every step. He's falling because it's headed somewhere his feet aren't. And once that happens, he's on a clock. That clock is about a quarter of a second. That's how long before it's too late to save. And this is what he has to do in that time. Throw a leg back underneath himself. How fast he can do that comes down to two things: how hard his hip can pull, and how heavy his leg is to swing. Rested, he makes it, with time to spare. Now watch what happens as he gets tired. A tired hip can't pull as hard, so the leg swings slower. But the falling doesn't slow down. Gravity doesn't care how tired he is. And right about here, with a slight increase of center of mass speed backwards, and 58% fatigue, the leg gets there too late. He misses it by under 2 milliseconds.